So good afternoon, everyone. I'm very happy to be here again. And thanks to the Hasgeek team, they've been pulling this off every year, and every year the conference has been going so well. Um, so what I'm going to talk about today is, sort of my own evolution of AI thinking, if you will. So I've been doing this for the last 20 years, and I've seen a lot of companies, products, ideas, and in a way, I just want to go through some of that and talk about what we need to go to next in our evolution of AI thinking beyond what we do today, right? And how will we build the products of the next decade, right? And think of it like, the moment when you realized what is object-oriented programming, your idea of programming thinking evolved, right? Or when you first learned about MapReduce, and then your idea of scale computing evolved, right? In the same way, I think we are on a verge of another evolution of our AI thinking, which is, so far we think this is what AI is. We build models, we do feature engineering, we do all of that. But what is it that, we need to think about when we go forward to the next level, right? So let me start with, my favorite quote. I think I almost start with this every time. And, connecting to the last speaker, so I was working with Ray Kurzweil at Google, and first day he came in and he said to the whole team, and we were all looking for a profound, first sentence from him, and he says, I want to build a humor detection system. And everybody stared at him, and then we all started laughing, and then he said, exactly, that's the point. So, sarcasm is definitely a very hard problem. Humor is another hard problem. And the point of this is that essentially all of AI, all of technology, not just AI and machine learning, but all of technology is really an extension of our own selves. And now let me tell you a little bit of, journey that people, companies, startups, countries take when they go through this journey, right? So we all start with what we call infrastructure, right? So if you look at how Google was built, or how LinkedIn was built, or how YouTube was built, or how Ola was built, they were all built with the basic infrastructure, which is, the databases, this and that. Or even if you think about how the, refineries are built, or chemical plants are built, or cities are built, they're all infrastructure first, right? And once we build infrastructure, we have been manually controlling those infrastructures, right? So the traffic police is controlling the traffic, or somebody is tweaking the knob, or somebody is picking up a phone call and, booking a cab. And then we start to go into automation. So that's our next evolution that happens, that all companies, all systems start with infrastructure. They go to automation. And once you start going to automation, you start to collect a lot of data. And then we all become a data company. So Google becomes a data company, Ola becomes a data company, Reliance becomes a data company. And they started off as infrastructure, then automation, then data company. And then we realize, we are sitting on a lot of data, right? And now what to do? And then all these companies evolve into AI companies, right? And that's the journey. Typically, you will see, if you do your sequence learning, you will see this kind of an evolution. More or less, we are all kind of following the same path. So now we are in this data and AI transition is where we are, right? Now, technology is obviously evolving in many ways, right? It's not just the deep learning, but many other things are evolving simultaneously. Our tools are evolving, our computing is evolving, our interfaces, our sensors, our data, and our idea of intelligence is also evolving, right? So when all these things are evolving, obviously two other things have to evolve, which is the idea of the product. See, what are the next generation products going to look like has to evolve. And to keep pace with that, how should our AI thinking evolve? Which is, we also have to evolve. So, before deep learning, we were doing other things. And then deep learning came and our AI thinking evolved to a next kind of AI, right? Now, from a business and a product point of view, how will our AI thinking evolve, right? So, just a quick recap on history, because it sets things in context and then we can go forward, right? So, our tools have been evolving, right? It's not that technology is something that happened in the last 10 years. It has been happening since the birth of mankind. Our tools have been evolving. Our sensors have been evolving, right? So if you look at any kind of sensor, not just telescopes, but medical sensors, remote sensing sensors, your cell phone sensors, all these sensors are evolving. So we are now able to collect more data at a higher resolution, at a higher throughput, and we can draw a lot more conclusions than we could before. Right? Our computing is evolving, and we are at this stage now. And 10 years from now, we'll see a quantum computer taking over and doing all things in our world, right? Our data is also evolving. So the idea is, all kinds of data, right? It's not just text, but all kinds of data. New kinds of data sources are emerging every day. And when we completed the Human Genome Project, or when we buy or sell a product, when we tweet something, we are evolving data. And now Internet of Things is going to come up and evolve further, right? So we are seeing that transition happening now. And all this I'm saying because all this has helped us see the transition from where we were to where we are going, right? Another thing that is evolving, if you've noticed, is the idea of the interface, right? So the idea of the interface is evolving. If you think about how interfaces were, we would desperately look for a UX designer to come up with the best UX design. And that's not how humans interface with each other, right? We don't say, oh, I want to talk to you, let me first download an app. That app will help me decide how to talk to you, right? We talk in a very natural manner, right? So nature has created natural interfaces for us to talk. So conversational versus UI-based, right? And then who likes to type here, right? We would rather say something and go from there, right? So if you see the evolution of UI, right? It is going towards speech and conversational more than apps and clicks and swipes and all that stuff, right? So this is happening, and all of you who are in the UX design world should start evolving your UX design thinking, yeah? What about knowledge, right? So there's another aspect of AI which I think I want to highlight before we go into something else. So if you think about AI and machine learning in general, what is it that we are really doing, all of us here, right? So think of it this way, that there is some reality that we don't know about, whether it's a reality about customer behavior or weather prediction or how the farms work or how the social network works. There is a reality out there. And when we sample a part of that reality, right? So we sample some data, and then what that data does is it constantly helps me discover and refine my current knowledge about the system, right? So for example, if you look at science and physics, we started with Apple falling and the Newtonian laws, then we applied that knowledge and say, oh, it doesn't work in the new framework of cosmology and quantum. So our knowledge had to, the new data is helping us evolve our knowledge about the physical world. Similarly, we cannot think of machine learning just as data, but it's a cycle between data and knowledge. And if you've seen projects like never-ending language learning kind of things, it's an idea of how does knowledge keep evolving, right? And when we do generalization on that, what we have in our minds is what I call a model of reality. So there is reality, and then we all have a different model of reality because we have seen different parts of the data. Now, what is very important to hear is this cycle, which is knowledge of what I have acquired till today helps me interpret the data that I'm going to receive tomorrow. And this cycle is very important. So if I've seen 100,000 videos, I hope not, but I've acquired certain knowledge about how to interpret images, how to interpret chairs, tables, and all that. That knowledge is now helping me interpret the next video, which is also helping me label the next set of data, which is helping me collect that data and helping me again build the knowledge on top of it, right? So AI is not a input-output process. It's a cycle of data to knowledge, right? And that's one way to look at it. And we constantly use previous knowledge to interpret new data, to label new data, and then use that data to again improve our knowledge. And that cycle is very important. That I learned over the last few years. How do you think about knowledge and data, right? And obviously our intelligence is evolving. So we have built tools around BI and reporting. We have built tools around machine learning, which only do prediction. We have also built tools around decision, right? On top of prediction, you cannot just say, oh, I know this email is sarcastic. You also have to say something like, hey, do you want to really send this to your manager, right? So you have to have a decision on top of prediction. And then why do you want to just do one-step decision and one-step action when you can actually explore all possible futures, right? So that's kind of the evolution of different kinds of AI that is happening. Uh, and now let me talk a little bit about what does it enable, right? If you think deeply, see, we get engrossed in, this kind of modeling technique, that kind of modeling technique. But really, if you think about what has AI done for mankind, if you have to explain this to your mom, how would you do it, right? And, from a decision point of view, right? So really, ultimately, it has evolved our decision making, right? So we have been making broadcast decisions, and now we are making very personalized decisions, right? So we've all seen personalization every which way, right? In, which Swiggy is going to personalize your food, and Flipkart is going to personalize your homepage, and Twitter is going to personalize something, and everybody is personalizing something for you. Netflix is personalizing something, and the most important personalization problems are not these. There are some more important personalization problems to be solved, but these give us an idea that AI can do personalization, right? And there's a very important phrase in statistics. It's called death by averages, because if I take all customers of this and do something with them, 90% of them may not like it. It's death by average, if you will, right? Another thing AI has done, it has helped us do batch to real-time decisions. So if you think about, for example, education is a batch system, right? Every day you come in, you study the same thing, again you study the same thing, there is a board exam, there is an exam. So it's a batch system, it's based on calendar, it's not based on real-time triggers, right? And we need to change that, because students don't learn in like a herd. They have questions whenever they have questions, right? They need to be answered whenever they need to be answered. It's not like a batch system. Another thing that AI has done is it has made us not react to what has happened, but to proactively predict something before it happens, right? So churn prediction, part failure prediction, any prediction, and then proactive to, reactive to proactive is what we can do now. Now, and then the last thing that AI does, it helps us go from what I call tactical decisions, which is, hey, let me just take this right turn here because I see that there's less cars on this side of the road, and then we are not making strategic decisions, right? What happens next? So the idea is AI can actually help you not make just tactical decisions now, but strategic decisions for the long term, right? So these are 4 things that really AI has enabled in all verticals that we talk about, right? All right, so obviously, AI itself has been evolving, and we are here because we understand the power of it. Data has become insights, rules have become models, listening has become hearing, looking has become seeing, reading to understanding. We are able to do a lot of complex things, and moves have become strategies, right? So a lot of things have happened in the evolution of AI itself, and AI is now like a 4-year-old who can do these 5 things well, right? Like a 4-year-old, it can understand a sentence, it can create a game and a rules of game and play a game. It cannot yet write a book, it cannot yet create a poem, but at least it can do these basic things, right? So now comes this part of where next, right? So in a way, 80% accuracy we have achieved in all these tasks, right? And now it's time to think about where we are going with this. Are we just going to keep improving these systems over and over again? Or we also need to start thinking of the next layer, which is where, I see the next evolution, which is, hey, the building blocks are all there now, right? I don't have to perfect a chair till I start thinking about the auditorium. I can keep perfecting the chair while I think about the next level of things, right? So I can do both things simultaneously. And the question is, how can we put them all together to not start thinking of products of the next decade, if you will, right? So let's look at the evolution of the products, how the products will evolve, and what has happened in the past, what will happen in the future, right? So if you look at products 1.0, these were products that, were physical products, right? You buy them and something comes home. And they had to be very reliable, right? Your TV should not break every now and then, your car should not break every now and then. And whatever smarts was supposed to be there was programmed into it, right? So they were programmed with the basic intelligence that, when your cell phone becomes dimmer or brighter depending on the lighting, it's a rule-based system that makes it work. You don't connect to the cloud and run a deep learning. It's a very simple act, and these simple things were programmed into the system, right? So these were product 1.0, and then we are now living in what we call product 2.0, right? Which is very different from product 1.0. We would have not imagined, if you had thought linearly, you would say the next generation products will just be better versions of TVs or better versions of cars. Yes, they are already happening, but in the meantime, something very leapfrog happened, which is we discovered the internet and the cloud and all this good stuff, and came all these applications that we saw in the last 10 years, 20 years, right? And that was the transition from 1 to 2, and these products are what we call virtual products, right? Most of them are virtual products. You don't get anything in the physical thing. And the thing that makes them smart is the crowd intelligence, right? We have given a lot of data or feedback to make these products smarter. So that is the data and the knowledge interaction we talked about, right? Which is, we have programmed these systems to become intelligent over time with usage. And this is one of the problems with a lot of products today. If you don't have usage, you don't have data, the products don't become smart, and then, then the usage goes down, right? So this cycle of usage, data, intelligence is what a lot of us are struggling with when we do startups and build AI products, right? Now, what do you think the next generation product will look like, right? And that is kind of the key question here, that we know how these products work, and we know what has made them what they are. What about the next generation of products? Are they just going to be better versions of LinkedIn or Google or YouTube or WhatsApp? Are they going to be different? The way version 1 to 2 were different, drastically different, right? Similarly, 2 to 3 have to be drastically different, right? And what they would be, so, we've already started to see talks about them, right? People are talking about connected car ecosystems, connected home ecosystems. We're talking about smart cities. So smart city is a product of the next decade, which we need to start thinking about now in order to say, okay, I know how to do this basic AI stuff. How do I build a product of the next decade, right? And that's where our, we'll be stretched in our AI thinking and say, you know what, a connected car ecosystem can be a lot smarter than all humans put together driving on a Bangalore street every day. Because imagine if the connected cars could actually figure out, and they'll say, no, don't start now, start 10 minutes later for work, and by the way, don't take that route, take the other route. I'm talking to other cars, and now I know where they are, and you'll be better off doing this, right? So this is way beyond Google. This is your car telling you when, when to start for office. But the idea is they are much smarter simply because they're connected together. And this is kind of the multi-agent thinking that has to come together. Today, all of us, or all our individual systems, make decisions based on limited knowledge, right? Right? And then we say, okay, what do I know from past? Therefore, I'll take this route, I'll start at this time. But everybody is doing it, and we are not aware of the other people, what they are thinking. So that's an evolution of AI that will happen when an AI system is able to connect multiple dots across and say, this is the most optimal for everyone, right? So the idea of crowdsourcing taken to the next level, right? So today, if you see Google Auto Suggestion, it's not that, it's there because all of us have been typing those queries and they start to show up. There's nothing Google about it, right? It's just an aggregation. Similarly, the power of this crowdsourcing, which is when collectively we cannot call everybody in the city and ask them, when are you starting, right? So then I can start accordingly. But the connected ecosystem of devices can actually do that, right? So think about that evolution. So that is one kind of evolution in AI thinking. I'm going to pose multiple such ideas in this context, right? Another kind of AI thinking is when you think about individual products. So let me go back to this one. So if you think about each of these, right, Google, YouTube, Facebook, and LinkedIn, what they've done is they've taken one beautiful idea, whether it is retrieval or recommendation or link prediction or what have you, and what they've done is they've taken that one core idea, put a whole bunch of infrastructure around it, and use that core idea to make these products smarter with the data that we provided, right? And that is kind of what the evolution of these products look like. They take one idea at a time, right? Google search is completely independent of advertising. They don't talk to each other in terms of the models, but the idea is, we've been building these products over time, but these are single-minded products using one kind of AI idea and then taking those products to the next level. Now, here's a glimpse of the product 3.0, another idea of evolution of AI thinking, right? So if you think about e-commerce, right, it takes a lot of work, 20 years to actually put together and perfect an e-commerce system. It's not easy. And the reason is, it takes so many kinds of modeling techniques to actually work together to make it work, right? And obviously, each of these, you may think they are all individual boxes, right? I can have teams for individual things and they can all work together on their own little problems, and we can create a microservices and the whole thing will work. That is okay from an architecture point of view. But if you look at the interaction between these things, is what makes these models more complex, right? So I'll give you some examples on that. Another product that I keep talking about is the teaching machine product, which is again going to need a lot of different kinds of AI modeling, right? It's going to need our ability to understand formula, handwritten language, languages, images. It should have the knowledge of the subject. It should know what the kid knows, what it doesn't know. It should know what the kid can apply and what it doesn't apply. It should know what kind of mistakes the kid is making. It should know what kind of behavior he has when he is stuck on a problem. So how do you profile a kid? And then how you use that to personalize the curriculum, what you should learn next, what is the right content for you that will basically match your learning style. What is the next problem I want to give you, right? I don't want to give you something which is too hard or too easy. So imagine if I could build a system that could just predict, what is the probability that you are going to be able to solve this problem, given what is your current state of learning, right? And then it says 0.1 or 0.9, then I don't give those problems because either they're too easy or too hard. I give them a problem which is 0.5 because that's what will make you go further, right? And if the last problem you did was wrong, I'll reduce that to 0.3 and give you that problem, right, instead of 0.5. So the idea is how personalization can actually help learning and education. We haven't even scratched the surface yet. We are still busy building recommendation engine for Netflix and Amazon and Flipkart. I think this is the real personalization problem that we all need to start thinking about, right? And it's a shame that we can personalize news and ads and search and emails and pizzas and phones, but we cannot personalize education yet, which was supposed to be the first use case of AI, right? And then a lot of these techniques like communication, right? How do you make the machines more human in terms of speech, conversation, gestures, and emotion, right? Now, the point of this slide is that if this is a product 3.0, look how our AI thinking has to evolve. We cannot say, I know one of these 5 things, so let me build this, right? We have to, and I think we are ready to do this now, right? We know how to do 80% of all of these. And we are now ready to start thinking how to put these things together to build complex systems. And that's what the call of this talk is, that how do we go and evolve our AI thinking and start thinking complex products like teaching machines, like smart cities, like connected car ecosystems, and while others are still working on improving this 80% to 90%. Yeah? All right, so how is the AI thinking evolving? So I worked at different companies and I've seen the companies evolving in their own AI. So this is how it was, right? This is how it looks like. When you look at a company today, a big company, this is how it looks like, right? So imagine a bank that said, oh, I don't have customers, I need a customer acquisition machine learning model, right? So they'll do market segmentation and there's one model sitting there doing that. Then they say, okay, now I have customers, I need to now start giving them offers, right, of the right products. I need a cross-sell and an upsell model. So then they'll build a cross-sell, upsell model, right? Then they'll say, oh, some of my customers are churning, I don't know why they are churning, I need a churn prediction model, right? So the idea was that over a period of time, these 50-year-old institutions have basically created a collection of models, right? One for this use case, one for that pain point, one for this prediction. And as they discovered pain points over the journey of their own evolution, they created models after models. And today, they look like a collection of models, which is, some of them are written in COBOL, some of them are in Spark, and now you don't know what to do with them, right? So now, we need to start rethinking our AI thinking in a different way, which is, this is how it looks like now, right? So, you go to any of the companies and they say, pricing is the most important problem, or churn is the most important problem, or whatever, personalization is and they are not talking to each other. They are thinking of their problems from their own perspective. And where we need to go is the next thing, which is how do we not think about a collection of models working as a microservices architecture, but really like a hierarchy of models, right? So if you think about, hey, certain models do very little things, right? They just come up with the loyalty score of a customer. Another model comes up with the value score of a customer. Another model comes up with the fraud score of a customer. Now, how do I use all of these three to do an offer for a customer or to do a churn prediction for a customer? So the idea is the models are not isolated or just input to output. The input of one it could be the output of the other. And this is the new architectural thinking we have to start thinking and saying what are the APIs around my AI models so that I can combine them in a certain way that makes the whole system work, right? And all that. So this is another kind of, so let me give you an example why we cannot think about input, output all the time, right? And why there is a loop in this whole process. So let's take a very simple example. So we have all seen, retail or Ola problems. So wherever there is demand and inventory, how this thing works, right? So if you think about demand and inventory, what do? You say, oh, my demand is very low, my inventory is very high. Let me call my offer generation model, it's going to generate an offer, right? So then that guy generates an offer, and I put that, and then that affects the demand now, right? So now demand goes up because I reduce the prices of something, all right? Then the new demand and the inventory, the pricing model kicks in, and it says, oh, you know what? Now the demand and supply looks, almost equal. Let me kick in and start to do some nice pricing now, right? So pricing comes in, and it does its own thing, right? Imagine if offer system and the pricing system were working independently of each other, right? Then what will happen? Then what happens? Pricing leads to, your profitability is one metric. Your conversion is another metric, right? This is what happens when you reduce the price, conversion goes up. Conversion leads to other metrics, cross-sell, upsell, acquisition, all what have you. And then conversion and demand leads to sale, and sale leads to, again, it affects inventory, right? So the idea is, now, the worst thing about Bayesian networks, for example, is we are scared of the loops, right? We don't want cause, effect going around. And here, there is a loop. In all machine learning models that we have seen, there is some kind of a loop if you think of them as collectively. So you can't really solve one problem in isolation of the other, right? You can't, for example, let's say at Ola, I cannot give customers a lot of offers and incentives and not do the same thing on the driver side because I'll have more customers and no drivers to back them up, right? So these models have to be thought through as a joint and not as individual problems. And that is a very important evolution in our AI thinking, that like you were optimizing your own traffic routes versus how to optimize the whole city. Same thing here. Let's say, okay, assume the AI models are doing their job. How do I optimize the collective as opposed to the individual now, right? All right, so let me quickly go through. So there's a lot of zoo of algorithms out there. I don't want to spend time on it. So we have algorithms of different kinds, right? I'm not going to talk about machine learning, supervised, unsupervised, but give you a different kind of flavor, right? So there is a lot of algorithms that are of type summarization, right? What is the market segment or customer segmentation and all that, right? Then there is a whole bunch of models we have seen which are around semantics, right? Understanding words, understanding languages, understanding sarcasm, understanding entities and relationships in a language, right? So we've seen a lot of work going on in semantic algorithms. Then we have seen a lot of work going on in extraction algorithms. So knowledge extraction from text, right, is a very important area. And if you read the top part, you will say, "Kehna kya chahte ho," right? In that movie, Three Idiots, it's basically a complex, convoluted sentence. But if I show you the graph of it, it's very simple, right? So how do you go from here to here? Another set of algorithms are working on that. Then we have solved a lot of interpretation problems, and interpretation doesn't mean only images or text, it means everything else. Gene sequences, this is a marker, this is anything that is assigned a value inside an object is an interpretation. So we've seen a lot of interpretation algorithms. We've seen a lot of prediction algorithms, right? So we don't want to talk about it. We understand what these are. And then we have seen a lot of recommendation algorithms, which are again, recommend this to that. And one of the key recommendation engine that we want to build now is this student recommendation engine, which says, given that this is what you know, what is the probability that you will do well in this next concept, right? So how do we build those kind of recommendation engines? Then we also have built a whole bunch of what we call reasoning algorithms. And how do you solve reasoning problems using AI, right? How do you think about sequence of actions as opposed to one action at a time, right? So now the point of this last 2 minutes was to say, hey, we have this zoo of algorithms out there, right? I don't know, which one is useful, when to apply what. I have this complex, industry to run, and I don't know how to deal with all this, right? How do I think cohesively about this chaos? Why are there so many types of models? Is there a universal architecture to AI that all these models fit in, right? That's what we are looking for. We are looking for coherence in this, right? Today, if you say, I want to do a machine learning course, there are these 1,000 courses in different areas, and you don't know where to start. And the reason is, we don't think about top-down. We are thinking one course, and one modeling technique, another modeling technique. And when you are on the other side, you start to think, is there a cohesion to all this, right? So that's what I want to talk about next, which is, what is an architecture of intelligence? And this is not something which is not us, right? We are all intelligent human beings, and we know what we do on a daily basis, right? What do we do on a daily basis when we make every decision? We do the same 4 or 5 things that a machine learning system does. So there's no difference between us and AI, right? So what we do, we have a stimulus. Stimulus is what your sensor data is showing you, what your logs are showing you. This is your stimulus, what your satellites are reading, what your customers are tapping on your app, what the cow path is on your website, right? So this is all your stimulus data. And then we analyze it and we build what we call states. And this transition is very important, which is how do you summarize the current state of a student in the learning path? How do you summarize the current journey of a customer in your this thing? What is the state of the system? How do you summarize for example, the state of the whole refinery in a vector, right? So what is the state of the system? And then what we do, we say, okay, if this is the state and I need to take an action, then I have a reasoning algorithm that tells me what is the metric, what is the action I should take. And once I take the action, I synthesize that action into a response, and then I get a response, right? And now what happens? There is no learning so far, right? We are all stimulus response systems, but we do have these 2 or 3 very important building blocks that are essential to all AI systems. Now you can apply this to every other system that you are thinking about. Not only that, what happens when you have a stimulus and a response? You get a feedback, right? So, you had fever and you took this medicine and the response was that you get cured or you didn't get cured, right? So there's a response, and then you have to think about how that response can be used to learn all the 3 AI systems, right? Did I interpret the input correctly? Did I reason about it correctly? And did I synthesize the answer correctly, right? So I'll give you a very simple example. So if you're crossing a road, it's a most AI task in the world, right? In India, crossing a road is an AI task, right? So what are you doing? You're sensing the road. You're saying, looking at the traffic on that side, and you're wondering if you should cross or not. And the idea of analysis is you're trying to figure out, is it safe or not, right? Is it safe or not? So there's a state of the system that you have in mind, which you want to figure out, right? And if you make a wrong judgment about how far the car is, how fast it is coming, the definition of your state will be different, right? And then you do your reasoning and you're thinking and you say, should I go, should I not go, should I stop now, should I run, and all that, and then you synthesize your action, right? So all AI systems you can think of in this way, whether you're building a speech to text to, what Google does, and it says, oh, I didn't understand what you're saying, is the analysis problem, right? I didn't know what answer to give you is the reasoning problem. If I know the answer that I want to give you, but I don't know how to say it, it's a synthesis problem, right? So the idea is, unless all 3 systems are working correctly, you are not going to be able to deliver a proper response to a stimulus, right? And when I say it, it's a broadest possible term, right? A query on Google is a stimulus, and the response is the search result, right? What you buy on Amazon is a query, in a way, stimulus, and what you recommend is a response, right? Now, if you want to think about all your machine learning algorithms, they kind of fall in these two buckets, right? There's a large class of algorithms that fall in your understanding systems. How do you convert your raw data into meaningful features or meaningful states, right? So a customer loyalty score is a point in a state, is a feature vector, right? Now that is not a raw input, you have extracted it or modeled it, right? Or an average over the last 3 days of something is a feature you have extracted. So these are your state vectors. They can be very simple or very complex. And on the other side, we are doing a lot of things to do prediction and reinforcement and all that to convert my state to the best action possible, right? So if you think holistically, every system, whether it is autonomous vehicle or a chemical plant or an e-commerce system or an education system or a farming system, right, goes through the same kind of thing. Yeah? So, in all of this, what is the most important innovation in the last 10 years that we have seen? Is it that we have improved our text understanding, speech understanding, vision understanding? So the understanding part we have improved quite a bit. And then those guys, recommendation engine and other things we have improved quite a bit. But what was the key to this whole thing? The key to this whole thing was not that, NVIDIA had a more powerful GPU. The key was not that, right? What was the key behind it was what we call the feedback data, right? So if I don't know if you've seen this movie, Alice in Wonderland, and somebody told me this sentence and I thought this is very apt for machine learning people to always think about. So here Alice is asking, what road do I take? And this cat is asking, well, where do you want to go? And if Alice says, I don't know, then she says that it doesn't matter if you don't know where you are going, any road will get you there, right? It's a very important principle that, machine learning doesn't start with downloading TensorFlow. It doesn't. Right? That's what we all think. Oh, I'm a data scientist, where is TensorFlow? And then I'll start doing something. That's not where machine learning starts. So let me tell you where it starts. So what this sentence really mean, how do we translate this into what we are trying to do, right? So what is the deep aspect of machine learning, right? So, hey, you want to build a churn model? Define churn. Now, churn is so different for, different groups of people, different kinds of customer behavior. Just defining what you are trying to predict itself is a problem, right? So if let's say in Geo we want to define churn, well, different people have different plans, right? Some plans expire in 2 weeks, some plans expire in 1 month. How do you define churn for all of them in the same way? There's no same definition of churn for all customers, right? So if I travel to other cities, I take Ola a lot, but if I'm in my own city, I don't take Ola a lot. Now define churn for me versus the guy who lives in a city and uses Ola to commute, the churn for that guy is different. And if saying that, oh, your engagement fell below this threshold for 14 days is churn, is a useless idea, right? So you understand that, the real essence of AI doesn't happen there, it happens with defining what you're trying to do, right? What is the default of a loan? A small business, a medium business, a large business, a farming business, a barber business, they all have a different idea of when they make money, when they're going to pay back their EMIs, right? You cannot define what is default same way for everyone, right? And we try to trivialize these kind of things, which is where we say, why is my model not working? Well, you haven't defined your metrics carefully yet, right? How do you define engagement, right? How do you define what is a valid click, right? I mean, Google spent years to figure out what is a valid click, right? So if you click on something and go to a page and immediately come back versus if you stay on it, there's a difference, right? And that becomes a valid click, right? Because click data is the most important feedback they need to maximize. What about ads? If you're a Pepsi or a Coke and you want to finish off the other person's ad revenue, what do? You put a bunch of people and say, keep clicking their ad whenever it comes, right? On the ad side. And then, if the ad engines start to believe that this is a real click, they're going to learn from that, right? So the idea of what is a valid ad click is also a complex problem. This is where complexity is in machine learning, right? How do you define classes, right? Should I just, like what he did earlier, is negative and positive emotions the same thing, or sentiments, or how do you take sarcasm out and then define rest of them together? That's where, you have to think about how do you break down your problem, right? And how do you formulate it as an optimization problem is what makes AI work, right? And not everything is just an input-output modeling. There's a whole bunch of optimization that we do on top of it, right? So what we have seen is the success of these companies is not just because of the great infrastructure and the scale and the crowdsourcing, but also how they use their feedback data very, very carefully, right? And they said, you know what, I'm going to define what is a right click. I'm going to, put the position bias into it. I'm going to not just look at the click, but the percentage of watched on a YouTube. I'm not just going to look at what you buy, but also look at what you browse, what you write, what you return, and then define what is your engagement with the product, right? So this is the depth at which we need to start thinking. This is another evolution of AI thinking, which is don't trivialize what you're measuring, focus on that, then focus on the features, then something nice will come out. Yeah? Another one of the favorite movies these days is this one, right? Incredibles. And one of the great things he said in the previous movie was this guy's syndrome, and he said something very, very profound. I think, I don't know if you've caught that. He said, when everyone is a super, no one will be. Right? When everyone is a super, no one will be. What does that mean in the context of us? Right? So let me tell you what that means, right? So, today, a lot of things have been democratized. Everybody is super. If you can pay for the cloud, we all have cloud. We're not different from each other in terms of the cloud, right? We all have the same cloud. We all have the same, modeling tools, right? We can download the same modeling tools. And we all know how to do the same kind of things, right? On real time or MapReduce and all. So none of us is special for these reasons, right? That's what, the good and bad about the open source is. Now, the big companies who have generously released all this for us to use, why would they do it if they knew that there was value in it? Right? Why would Amazon open up AWS and say, yeah, Flipkart, you can use AWS all day long. And by the way, I'm your competitor, but that's okay. You can still use AWS. What is Amazon thinking, right? Why would Google release all of its search infrastructure and say, you can build your own search engines? What is it that they know that you do not have, which is what really makes them different? What makes them special? And these things are not it. Right? What data, right? So web, everybody can crawl. But what is real data in that is not the web data. That everybody has access to. I could build a crawler to collect the same amount of Google web data that Google has, right? That's not what makes me special. What makes us special is the labeled data, right? And that's what I think a lot of us need to think about in our data strategy, right? We keep thinking about how will I store the logs, right? How will I scale and do some BI on top of it? But the most important thing that we need to think about in our product journey is how will I collect label data? Because that is what makes me unique, because that is my label data now, right? So Flipkart's data about what people bought there, or Reliance data about who calls and what are the call patterns in the city, or Ola's data about, that is their data that makes them special. Not these things, right? So never say, I know TensorFlow, therefore I'm a special data scientist, right? I know how to deal with label data. The biggest innovation in the last 10 years that nobody talks about is this art of collecting label data, So I'll give you an example. So imagine if all the farmers in India are incentivized to click pictures of their farms, okay? And now we have the ISRO satellites that are roaming around Earth. And now if we could make the connection that computer vision tells me that this is a wheat at stage 3, and this is how the satellite data looks like. If I can tie these two together, then I can now actually predict the yield of the country very quickly, because now I know which crop in which field is at what stage, and I know it because I was able to use the label data which a farmer is giving me with the pictures connected to the global data, the unsupervised data on the thing. This is where our AI thinking has to evolve, which is not just sit in your own silo and say, okay, I'm going to do this on my data. Start thinking, how will I connect multiple such sources of data to then create a new kind of AI, which is far more powerful than our simple things that we do. Yeah? All right. So let me just quickly give you another idea of AI evolution, which is around what makes products 3.0 far more complex than product 2.0, right? So if you think about Google, it's a collection of models still, right? YouTube recommendation is different. You know, what they do on Gmail is different, ads is different, search is different, right? They're all different models. They all work very nicely and we all use them and we are happy. What is the difference between that and a new kind of product that is, let's say, a fleet management system, right? So here, what's going on is you have many types of stimulus, the Ola app and this app. You have to convert this to a higher order set of features, right? So what are my customer models? What are my driver models, right? What are my demand prediction models in location and time? So you have to come up with these states. Remember we talked about stimulus to state, and then these states have to then be converted to a lot of different actions. Now search has only one action, right? LinkedIn, when it recommends people, has only one action. But now you have many actions. Simultaneously, you can take many actions. Which one is the best action, given this complex definition of the state? And then, what is even more difficult is, now I have a bunch of metrics that say, how many people got the cab, how many people paid higher than normal, how many drivers were wasting their time waiting for a service and all that. So when I look at this complexity, which is the state itself is complex, you have to think about all entities throughout the city at all times, at all locations, is a state vector, right? Then you have to think about what are all the responses I have, and then you have to think about the most difficult part is which combination of responses led to which combination of metrics, because they are all intertangled with each other. And that is what makes product 3.0 more difficult than product 2.0, right? Hopefully, that went along. So the idea is, this is the next level of AI thinking, which is not possible with traditional modeling anymore. You have to almost build a simulator to say, what if I do this, what if I do this, what if I do this, what will happen to all the metrics? And the simulator is the next source of data, right? GAN's simulator. Simulator is what is going to be able to give you the amount of data you need to do this kind of complex modeling. So let me now reduce it to 5 things, right? So we have talked about different things. So really, you can reduce all your AI into these 5 things, right? What are my metrics? What is the knowledge I already know? What is the data I collect? How can I extract features or states out of it? And given the state, what is the response I should give, right? And you can do the same thing in every domain. You can say, I want to optimize my refinery. I'll do the same thing. I want to define what metrics are. What is the knowledge? What is the stimulus? What is the state? What is the response, right? If you can take that 5-dimensional thing and keep doing it in any domain, you will have a very clear way to think about it. It's a template of thinking about AI, right? I can apply this to education. I can say the same thing about education. And say, these are my metrics. This is what I know. This is the stimulus data. This is what the feature is, and so on. And I can apply this to agriculture, and I can do the same thing, right? So I can say the same 5 things, and if I can learn, now I'm learning only 2 kinds of models here. One is the state to response models, and one is stimulus to state models, right? So the analysis and the reasoning and stimulus models. All right, so let me now quickly switch gears and talk about another idea of evolution of AI, right? Which is a different way of looking at it. So obviously, Jeff Hinton has given up on what we call deep learning now, right? And he's moved on. While we are still downloading TensorFlow and buying NVIDIA GPUs, people have moved on, right? So, the new AI is coming, right? And you've seen the glimpses of it. So let me ask you some simple things, right? And we've talked about this earlier, but the idea is, we are very hung up on embeddings, but you know what? Embeddings don't really make sense when they are not about the same type of entity, right? Or it's not about the same. You cannot compare Bangalore with Progressive. It's a different kind of relationship. You can mathematically compute the cosine similarity, but that is not meaningful, right? So embeddings take you in a place where you stop thinking about, is this what we really need, right? And you can only do embeddings even within nouns of the same type of nouns. You cannot compare Bangalore with Taj Mahal, for example, right? That embedding will have a number, but it doesn't mean anything, right? To a machine, it doesn't know that. And when you're doing sentences and whatever with embeddings, it doesn't know all these things. It will still take dot products, the LSTM will do what it has to do, but it doesn't know that these embeddings are not supposed to be in the same space at all. Another question I want to raise is this how we do machine translation, right? I mean, all our kids learn multiple languages, but is this how we teach them, right? And today, the world is full of machine translation systems based on parallel corpus. Now, if I want to build a machine translation system for all Indian languages, I don't have parallel corpus for Odia to Punjabi, right? How will I build? So now I have to think differently about how to do these kind of tasks which have been traditionally done in a data-rich environment, right, at a lot of cost of collecting this parallel corpus. How will I do this across 20 languages, right? It's very easy to do English to X because we have a lot of data, but now how do you do it across 20 languages is the next challenge that I want to throw at this community and say, can you do that, right? Without having the parallel corpus. So we'll have to evolve new ideas about translation from scratch, right? And we've talked about this earlier. This is not how we learn to see. Another thing that is very interesting I've been thinking about is today when we do our object recognition and all, we only think about the box and say this is a cow, but what if the rest of the things around it are not, is something else? What about the context? Because context plays a lot of role in us determining what this object is, right? So how do we take context into account in our vision system is still something that is an open problem that we need to think about, right? Another interesting thing I'm thinking is, hey, we don't learn to hear and we don't learn to speak as two independent problems. We do them jointly, right? When I'm speaking something, I'm also hearing it. And therefore, I'm able to train both my vocal cord and my hearing system simultaneously. These are not disjoint problems. So when I say evolution of AI thinking, 10 minutes? Then this is the kind of thing I'm looking for, which is how do I think about all these different areas of AI thinking, right? So now I want to touch upon finally on the new wave that is happening in India, right? If you've seen the Niti Aayog thing, if you've seen what Wadhwani Group and Microsoft and a lot of Google, all the companies are now working for better use cases of AI, right? Because what we've done so far is we have figured a little bit out. We have used them on very commercial use cases, ads, marketing, segmentation, churn, all that good stuff, but we haven't yet used it for the greater good of society, right? So I think, we are definitely in a very interesting time, and if you are going to just waste it on, more commercial applications, more, algorithmic trading and things like that, I think we would lose a very big opportunity to make a big difference in society, right? So, what we are doing is we are trying to build AI stack for India, if you will, right? Try to do machine translation in India, speech to text in Indian languages, with all the accent and the cows in the background and all the noise, right? Try to do all these things here, and this is where AI will really be challenged, right? Not in the US where everybody knows how to drive on a lane, and autonomous vehicles can drive there, right? And everybody speaks English, or in China, everybody speaks one language. Speech is easy there, right? How do you do it in countries like us? And then once you build this kind of an AI stack, how do you use that to solve the real use cases that the country needs right now, right? How do you help, the farmers are still committing suicide. What is the point of you recommending a better product to a customer? When our farmers are still committing suicide, our students are still suffering from bad teachers, what is the point of being an algorithmic trader making a lot of money? So I want to start thinking, this is another evolution of AI, which is about where we should really use it, right? And we haven't yet used it for the right things. And I think now that we have made enough money on those problems, it is time to start using it for the betterment of mankind, right? All right, so here are some of the guiding principles. And, I'll just go through them, but tell you why they're like startling to me, right? So one is, so when I went to Jio and Reliance, one of the quotations I read was, supply creates demand. So at Ola, I was thinking all along that demand is organic, and you have to make sure supply is enough for the demand. And then when I go to Jio, I realize it's the opposite, right? And then I thought about it for a week and I said, what does this really mean? Supply creates demand, right? And if you look at it in our own context, a lot of people say, no, farmers don't need AI, students don't need AI, only these big companies need AI. But if you supply them these possibilities, that a farmer can actually talk in his language to a knowledge graph in the back, connected to content systems in all languages, and it can personalize and retrieve that content for him with a phone call or a picture. We haven't created that supply. We don't know that there is demand. There's so much demand, right? So that is how I interpret that. Another thing that I'm seeing is a lot of these Kaggle competitions and tech geeks and all are making us very narrow-minded data scientists, right? All we think about is accuracy, 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 and beating the next guy to it, right? I think we need to start thinking solutions rather than models, right? And say, let me step back, go talk to farmers, talk to students, talk to teachers, and say, what is your pain point? Don't let PMs do that, because PMs are limited by their idea of what AI can do. But we are not. So we need to step into that role and start assessing the pain points of the country. And you don't have to go too far, right? Just talk to your own kids and see how well they enjoy their school, right? Or go out and look at the potholes around you or the traffic problems. So start thinking solutions which will require a lot more things, but also AI, which is a small part of it. And then you will create a better AI system when you know how it fits into the overall solution, right? Another thing is we love to build models, right? We say, oh, Jupyter Notebook, blah, 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 and then I have a model out, right? And we love to do that because that's what we do, right? We are data scientists. But, how long will you do it? Will you do it every day when the model is needed, right? So ultimately, we need a modeling platform, not a model. So don't even waste your time building a model. What I'm saying is start thinking about modeling platform and use the platform to build your first model. That way, your efficiency will go up. You can try many things and you will not have problems with deployment and other issues, right? And please find real use cases, right? I hear a lot of startup ideas around, oh, I want to build a robot that can wrinkle the clothes properly and vision and wrinkle detection. Please find real use cases, right? I think they're all over the place. And hopefully, we'll go beyond commerce and convenience, right, at some point. And, one of the greatest things about us is, if you can do it in India, you can do anywhere, right? So whether it is autonomous vehicle or, machine translation or speech, right? So don't look for jobs in the US. Don't worry about it, The real challenges are not there, right? Their real challenges are here. So I want to make, AI for India as the sexiest job for a data scientist, not AI for whatever, right? Goldman Sachs. All right. So how are we doing on time? I want to share a video. Huh? Okay, good. So what I will do is I'll skip the whole question answer thing. You can catch me outside. I wanted to show you a video which is also about evolution of AI thinking, but this is 300 years into the future. Has nothing to do with all this. I've been wanting to show this video for the last 4 conferences, but the time was not permitting. So I'll show you one video. Is there a way to turn the lights dim? Okay. So it's like a 5-6 minute video. All right, so let me see if it plays. Volume? Jack is there. Volume is not controllable here. Let me try it out.
Yes. Suffice it to say, he's an expert.
All right. So I just wanted to end with that. This is another evolution of AI thinking, which is, we build these intelligent products, but eventually what will happen? One day if they have consciousness, how will we start thinking about them differently? All right, so I'll stop there and